Hello everyone, welcome to Math 20-1, Lesson 2, Vertex form. We are still in the Quadratics unit. So in this unit, we are going to be looking at a different form for quadratic functions called vertex form. Now, going back to what we did in Lesson 1, we want to make sure that we understand the parts of a parabola or quadratic function. We want to understand that it can open either up or down, but never sideways. We want to remember what the vertex is. It's that part where it changes direction. We want to know that a vertex can either be a maximum, and this happens when it's opening down, and it can be a minimum, and that happens when it's opening up. And that imaginary line that cuts the parabola in two, well, that's called the axis of symmetry, and the equation of the axis of symmetry can be x equals p, where p is the x value the axis of symmetry goes through. In other words, it's a value on the x-axis. Now, if you haven't already, you can head over to the course website and you can get in there and answer a few questions in that Activate section. So let's head on into vertex form. Well, vertex form can be written in a little bit of a different way than standard form. Remember, standard form was y equals ax squared plus dx plus c, where vertex form is y equals a and p and q. So y equals x minus p squared plus q. It is called vertex form because that p and q make up the ordered pair of the vertex. So in other words, we can have p and q will tell us exactly where the vertex is for the parabola. So knowing that, I want you to take a moment, pause the video, and see what you think that the vertexes of these four functions. Okay, how did you do? Well, for the first one here, I want you to keep in mind that this has a subtraction sign, as does this. This means the p-value of this one is 2, and the q value is 3. Same for this one. It may look like -10, but it's actually 10, and this is 1. Same with this one. It looks like -1, but it's 1. And this time we have a -5 for the q. And this one, you're going to flip that again. It looks like +3, but it's actually a -3. And this is -12. So we want to be careful when we're using this one, that we are taking into account that this subtraction sign is here, and that is going to flip the sign of the p, so to speak. Well, we know that in standard form, the a value had a special function. It told us really if it was opening up or down. We also knew that c had a special function. It was the y-intercept. But now we're going to look at the special information A, P, and Q give us. So let's get started with A and look at what is the effect of A on a quadratic function. So what I've done here, I've introduced 5 different quadratic functions, with the original being y equals x squared. And I've made myself a table of values. So all I've done there is I've picked some negatives and positives and 0. And all I'm doing is I'm taking the x value, plugging it in, just like that, to get the y. So the input is x, the output is y. And I've done that for these 5 functions. Notice that I varied the a value. Now in this one, even though it's not written in there, the first one, that has an a value of 1. Then we have 2. We have 0.5 or a half. This one has a negative. Well, remember it's not there, but it's implied. It's the -1 there. And y equals -2. And then down here, I've graphed them. And I want you to take a look and notice what a does when we have positive a values, negative a values. And look at what happens when a is above 1 and a is below 1. In other words, a is above 1 is 2, a is below 1 like a half. Look right here. So the red represents the original. We notice right away that if they had negatives, those are opening down. This is the same thing that happened in standard form. A negative a opened down. Positive a's opens up. Now what about for these different values of a greater than 2? Well, notice when a was greater than 2, this graph, this yellow graph right here, this one looks narrower. Whereas when a is smaller than that 1 value, it's wider. So it's kind of a little opposite to what we might think. So let's summarize this together. Down at the bottom, right here. So it says if a is greater than 1, or in other words, -1, because it could be the case we have -2. Notice in this graph right here at the bottom that -1 is wider than the negative x squared. That the parabola is narrower than y equals x. So let's write that down. Okay. Let's look at this one here and summarize our findings. The graph of y equals ax squared is the graph of y equals x squared transformed as follows. In other words, how does it behave? Well, if a is greater than 1, for instance, when we went from x squared to y equals 2x squared, or a equals -x squared to -2, so notice it's outside of these areas, we say that the parabola is narrower than x squared. And if a is between -1 and 1, in other words, it's a decimal or fraction. Oops, we forgot something. A cannot equal 0. Because if a equals 0, then there is no quadratic portion. We say that it is wider than the x squared function. Now, going back to standard form, same thing applies. If a is positive, the graph opens up, and if the a is negative, it opens down. Okay, let's look at what happens when we change q. So what we've done here, notice we started with that original y equals x squared, and we have changed the value that is added to the end. So creating a table of values, feel free to check the work. If you find any mistakes, let me know. We've gone ahead and we've plotted each one of these graphs. Now, when we've done that, look what happens here. We have that red y equals x squared in the middle. As we added 1 on the end, it's gone up. And as we added 2 on the end, it's gone up. But when we subtracted 1, it's gone down. And when we subtracted 2, it's gone down by 2. So notice that effect. In other words, if Q is greater than 0, we say, and here's some fancy new words for us, we say that the parabola is translated Q units up. And translate is just a word for move. If Q is less than 0, then the graph is translated Q units. Now, Q can be any number, as we seen. It could be a positive or a negative number. But if it's negative, the graph goes down. So that's the effect of Q. Now the effects of P, what do you think? Well, we've got the thing with A is stretching or squishing the graph, making it narrower or wider. Q makes it up or down. And if you've guessed, P makes it go left or right. You are correct. Again, we're starting with y equals x squared. And notice inside the brackets, we've changed the p-value. Remember, the original function has this negative in the bit right here. So that just means we have to keep in mind of p being positive or negative. For instance, in this one right here, I would actually rewrite this to make it look like that one by doing this. So I say y equals x minus negative 1 squared. When I do that and simplify it, it comes back to the positive. So let's look at the bottom here. Well, notice here, the yellow and the green go to the right. And for the purple and the pink, or the blue and the pink, it goes to the left right here. So in other words, when P is positive, it goes to the right. When P is negative, it goes to the left. So let's write that down. So in this one, the parabola is that word again, translated. P units right. And when it's negative, the parabola is translated P units left. So we have to be careful. We have to make sure that we're thinking of it as that negative bit right in there. Now, another thing is, the nice thing about that p-value is it actually is the same thing as the axis of symmetry. Remember the good old axis of symmetry? Well, that p-value, notice there, our p-value is -2, and the axis of symmetry is -2. Same for this one. The P is -1. The axis of symmetry is -1. The P is 0. The axis of symmetry is 0. Let's keep going. P is +1. Axis of symmetry is 1. And P is 2. Axis of symmetry is 2. And so in other words, we write this as an equation. And we just say x equals -1, x equals 0, x equals 1, and x equals 2. So these are the axes of symmetry. And so in general, the axis of symmetry has the equation x equals p, whatever p might be. Okay, let's keep moving and putting it all together. Now, while we have looked at A, P, and Q individually, we might have an equation that has all three numbers put in. And let's look at what that means. Well, in general, let me just grab my highlighter here. For A, that determines the opening direction. And here's a new word, concavity. Concavity just means how it is curved. It is a curve with the bowl part facing up or curve with the bowl part facing down. So if it is opening upwards, we say it is concave up, and we know that happens when A is greater than 0. It's the same in standard and vertex form. If A is less than 0, it is concave down. We know that if the absolute value of A, for instance, in our previous example, when A was 2 or -2, it appeared narrower, but as A was between -1 and 1, where A does not equal 0, in other words, a fraction or a decimal, we found it got wider. Now we learned that P determines whether it's going left or right, or in other words, it's a shift horizontally. If P is greater than 0, it goes to the right, and left if P is less than 0. And for Q, it shifts vertically up if Q is greater than 0, and vertically down if Q is less than 0. We know that the vertex location is at P and Q, and the axis of symmetry will be x equals P. So notice here, we start with that original function y equals x squared, where the vertex is 0 and 0. But let's notice what happens as we change P or Q. For instance, in this one right here, look what happens when P is 1 but Q is 0. Well, we get that vertical shift right here where the axis of symmetry is now x equals 1. For the next one here, when y equals x squared plus 2, notice the original graph gets pushed up. The axis of symmetry is still 0, but that vertex now is 0 and 2. But let's look what happens when we put them both together. Well, we have P is 1, Q is 2, and sure enough, this is 1, this is 2, and that axis of symmetry is at x equal to 1. So changing the graph with parameters P and Q shifts the vertex from 0 to 0 to this new P and Q. No, not separated in the formatting. P moves the vertex left or right, and the new x-coordinate is P. Q adjusts it up or down, and the new y-coordinate is Q. The vertex, let's say it one more time, is P and Q, and the axis of symmetry is X equals P. So let's see if you can remember this and organize it into this nice table, and let me know what you come up with. Maybe pause the video just a moment, fill it in, and then I'll go through it with you. Okay, so if A is between -1 and 1, and remember, A cannot equal 0. One day I'll fix these notes. The graph rises slower and it appears wider than the graph of y equals x squared. If A is less than -1 or A is greater than 1, the graph rises faster, means it looks more steep, and it appears narrower than the original graph of y equals x squared. If A is positive, the graph will open, and if A is negative, the graph will open down. P gives the x-coordinate of the vertex, and therefore the equation of the axis of symmetry. I hope you got that one. If you put that, that's great. Equation of axis of symmetry. And if you said, x equals P, that's cool too. Now, Q gives the y-coordinate of the vertex, but it also gives what is the minimum or the maximum. Remember, because if it depends on A. If A is greater than 0, then it's going to be a minimum, and it's going to be a maximum if A is less than 0. Let's do a few examples. Let's look here. In this question, it says match the numbered graph above to the one of the equations below. So there's our 4 equations. Ask us to match them up with the number. So we need to look at what is the A and vertex of each of these. Well, let's look at this. In this case here, it's opening up. We know A is greater than 0 because it opens up. We also know the vertex is 1 and 2, which means P equals 1, Q equals 2. Looking at that, we might think it could be this one or this one, because this one has a P of 1 and 2. But notice that one of these has a 2, and this one, we don't write it in, but it has a 1. Well, we need to look for another graph opening up that has a vertex of 1 or 2, and that just happens to be this one. So, and again, A is greater than 0. But because they have the same vertex, and we see that 2, we'll call that 2 is narrower than 1, that means that the A value of 2, because it's narrower, it must be greater than the A value of 1. So in other words, This first one here is 2, and this one is 1. Well, we got those sorted out pretty quick. Let's look at the next one here. Well, this one here, it has a vertex of -2 and 1. And it has an A value that is greater than 0. Well, notice again, these both have a vertex of -2 and 1. But because A is greater than 0, that must be 1 right there. So this one is 3. And by elimination, this one is 4. But you can always check it. Of course, it's opening down. A is less than 0. And the vertex is -1, -2, and 1. Now, this is a numeric response style question. So in an exam, you would fill in your spaces 2, 1, 3, and 4. All right, let's look at this question. It says, draw the graph of the function y equals x minus 1 squared. I want you to take a moment to do this by creating a table of values if you wish, and come back and I'll have the graph drawn for you. Okay, so here it is. And notice we know the value here of P and Q, which means the vertex is 1 and -4. And sure enough, we have this 1 and -4. And then we just pick some other values. Notice I picked between -2 and +3. And so if you take that and plug those values in, let's do a -1 first. Let's say we want what is y when x equals -2. We go -2 minus 1 squared minus 4, like that. That means y equals -2 minus 1 is -3, but -3 squared is +9. So 9 minus 4 and y equals 5. So that's where this point comes from. If we pick another value, say 2, and we do the same thing, like that. This one here, 2 minus 1 is -1. -1 squared is 1 minus 4. And that equals -3, like that. So that's where this point comes from right here. So from this, let's answer some of these questions. Well, we already know the vertex is 1 and -4. We also know just by even looking at the graph, because the A is greater than 0, we know that this is opening up. The axis of symmetry comes from the p-value. Let's draw that in. Let's draw in our axis of symmetry. Well, that goes right through the middle, which means it goes through the p-value. And so it is x equals a +1. We know that because this opens up, we are going to have a minimum value. And the minimum y value in this case is the q value. It's y equals -4. Look at that. These have two x-intercepts. It has one here, and I've already circled the other one. And so it is going to be -1 and 0. Remember, x-intercepts have y values of 0. And -1 and 0, and 0. Oops, back that up. 3 and 0. And the y-intercept, is 0 and -3. And we can solve these intercepts not only by looking at the graph, we can solve them algebraically as well. We'll do some of those a little later on. Now the domain. Well, this goes to the right in that direction. Notice it's veering off to the left in that direction. So that means the domain is going to go to positive and negative infinity. So if we wrote this in interval notation, it would be like this. But we can also write it in set notation like that. We also know the range. Notice here, this graph is increasing this way and increasing here, but it's not increasing down. We're not going down here. So the minimum value becomes the lower limit of the range, and that just keeps going into infinity. And if we wrote that in set notation, remembering that we have to have a y, that this is going to be -4 is the minimum, less than or equal to, because it can be -4, y, and y is an element of the real numbers. Now the next part, it says, explain how the graph and the characteristics would change if the function now had a negative in the front. What things do you think would change? Well, everything, the vertex would stay the same, but now this thing, rather than opening up from that point, is now going to open down from that point. So the only thing that stays the same of all of these characteristics would be the vertex. This now changes. The axis of symmetry stays the same. The minimum now becomes a maximum right here. The x-intercepts, they no longer exist for the second one. And the y-intercept changes. And the domain stays the same, but the range now changes. So notice really there's only a few things that stay the same by switching the a value. Vertex, axis of symmetry, the value of the maximum is same as the value of the minimum of the other one, and the domain. So we can write that as the new a value. Oops, that's supposed to be quotation marks. It looks terrible. I don't think that's better, but is -1. Therefore, the parabola opens down. And the vertex is still, oops, and the vertex is still 1 and -4, but this is now a maximum. And if you want, you can say there's no x-intercepts. And any other thing you think is relevant. Okay, let's look at 3. Identify a, p, q values in the function y equals -2, x minus 3 squared plus 7, and describe the transformations that each parameter is performing on the graph y equals x squared. Well, the first thing is that with the a value, it's positive, so it opens up. Oh, sorry, it's negative, so it opens down. Let's change that. A equals -2. So because it is -2, and 2 is less than -1, it's going to be narrower. Even though the number itself gets bigger, it's narrower than y equals x squared. Let's look at p. Well, p equals 3, so that's the same thing as let's use that fancy new word, horizontal stretch. Not horizontal stretch, horizontal translation. 3 units. Now, because it's positive, it's going to the right. And let's look at the Q value. Q equals 7, and that's a vertical, and that new word again, translation. Seven units. Now, because it's positive, it's going up. And there's our descriptions. Okay, let's look at question 4. Write the function in vertex form y equals a times x minus p squared plus q for a parabola y equals x squared that has vertically stretched by a factor of 2/3 and then translated up 3 units. Well, it's vertically stretched by a factor of 2/3. That means the a value equals 2/3. And because it's translated 3 units up, that means the q must equal 3. Now, because there is no translation left or right, that means the p value equals 0. Now, putting this all together, we can have y equals 2/3 x minus, well, we don't have a p-value, so we actually don't even need to put this in brackets anymore. We can say x squared plus 3. We could also write this a little bit of a different way with the brackets in there, but again, it's not necessary for this question. Let's look at number 5. Determine the vertex, direction of opening, equation of the axis of symmetry, maximum or minimum value of the quadratic function f of x equals -0.5 x minus 2 squared plus 8 by inspection. And how could we check? Well, we know the vertex is P and Q. In this case, let's write out what A, P, and Q are. Our A value is -0.5. Our P value, remember, it's opposite to that sign that we see, it's 2. And Q equals 8. So that means the vertex is 2 and 8. It means the axis of symmetry comes from the p-value, and that means that's x equal to 2. Remember that the maximum value or minimum value comes from the y value, but we need to look at a. Well, because a is less than 0, this opens down. So in other words, as a quick sketch, it's going to look something like that, where this is 2 and 8 right here. And because it opens down, we know that y equals 8 then must be a maximum. Now, with all quadratic functions, we know that the domain is x is all the real numbers. And let's put in the range anyways. The question doesn't ask for it, but the range is from that minimum value down. So y such that lower end of that is 8, and everything below it. So in other words, that is, let me switch this around here. Y is less than or equal to 8. So the lower and the upper, where y is an element of the real, and you can also write this in interval notation. Question doesn't ask for it, but it's always good to know. Did we miss anything? Vertex opens up, equation, maximum min, and how can we check? We can check this if we wanted to by graphing it. So go ahead, you can check it, make sure that you use those calculator features to find vertex, axis of symmetry, things like that. Well, now it's time for you. You're going to go ahead and practice some questions. Questions 1A and 2A from the practice work. If you are an asynchronous student, I do want you to check in with me. I want you to let me know in an email how you're doing. Good or not so good if you're having trouble. Make sure you include any pictures of your work so that I can help you out. Okay. Well, now that we know what vertex form is and all the little parts of the equation, we can actually use our knowledge of that to write the equation of a graph when we're given the graph. And we do that by looking at the graph, first of all, to determine the vertex, because the vertex is going to give us P and Q. Now, for the value of A, there's two things we can do. We compare the shape of the graph with the shape of y equals x squared, but we'd have to be kind of really good at doing that, and that's not really always going to be a great option for getting exact values. So we don't want to use this not used much. But for this one, substituting the P and Q from the vertex and the X and Y from another known point and solve the equation, that's a keeper. And then we can write that in our vertex. So let's look at the first example here. Well, in this, we definitely know the vertex. We know the vertex is 2 and 4. And we definitely know another point. We got a couple. And here's the thing. You can pick any point. Pick your favorite. I'm going to say this one here is my favorite. So I'm going to call that point 5 and 1. And we're just going to hold on to that one. We're not going to use it quite yet. So we're going to start by substituting in our P and our Q. So I'm going to say X minus 2. Remember, we have to do that kind of flip in our head. Plus 4, like that. I'm going to take my value of my X and a Y, which in my favorite point, and I'm going to put the Y value here, and I'm going to pick the X value here. Now, notice now we can solve for A because we have numbers everywhere else. So order of operations, brackets first, then exponents. Multiplying, dividing left to right, or adding and subtracting. We got to get rid of these. In this case, remember, because we are solving for a, we have to add or subtract before we multiply or divide. So this gives us a -3 is 9a. Now we can divide. That's supposed to be 9s. They look like terrible a's. And so I'm just going to bring this up. Remember, we always have to work vertically downwards. No writing across. So we're going to say a equals -3/9 reduced is -1/3. And we want to always reduce, okay? Now let's plug in what we know. And there we go. So that's an algebraic way of putting things together. Let's look at this last question here, number 7. The parabola with a vertex of 5 and -8. The x-intercept is at 1 or 9. Well, what is an x-intercept? It's actually a point with y equal to 0. So we actually have 2 extra points to work with. And the nice thing is you can pick your favorite. So writing down our vertex form here, we can start by filling in our P and Q of the vertex. Again, taking care of the signs. We have that right here. And we are going to substitute in one of the points. I like working with smaller numbers, so I'm going to say 1 and 0. And I'm going to start simplifying. I'm going to do those brackets in there and get those. 1 minus 5 is -4. And that's the same thing as 16. You can write the 16 in front of the A if you wish. We're going to add 8 to both sides. And that's going to give me 8 equals 16a. There, see, I did it. And then that means I'm going to come up over here. And that means A equals 8/16. Or reduce down always, A equals 1/2. Now putting that all together back into vertex form, y equals 1/2 x minus 5 squared and minus 8. Remember, if you have any questions along the way, always get in touch with your teacher. And the last question, it says, using a quick sketch, determine how many x-intercepts you have. Now, this is a super cool question, and it's a nice one on exams. Let's look at this. Y equals x minus 3 squared plus 1. Well, what do we know here? Well, we know the A is positive because it equals 1. So A is greater than 0. We know it opens up. That's a terrible U. That's not much better, but let's go with it. And we know the vertex is 3 and 1. So if we sketch this, well, 3 is 3, about there, and then go up to 1. Because this is opening up, it's going to go something like that. That means it's actually not going to cross the x-axis. So there are no x-intercepts. Now, it doesn't ask us what they are, so this is all we have to do. Tell how many. Let's look at this one. Well, in this one, a is less than 0. So we know it opens down. Now, what's our vertex? Well, P is not here under that square sign. So that means our P is 0. And our Q is 7. So if we do a little sketch of this one, the vertex is actually going to be on the x-axis and it opens down. So it's going to look something like this. We don't know exactly, but it's going to look something. This means there are going to be 2 x-intercepts. Let's look at this one. Again, we have a less than 0, and our vertex is 0 and -5. Well, 0 and -5, that's below right here. It's less than, so it opens down like that. So this one has no intercepts. And the last one here, A is negative. Key is 1, so the vertex is 1, and this time it's 1 and 0. So it's, oops, that's the origin. We got to go 1. 1 and 0 would be kind of over here. And A, so it's going to go look like that. And this one has 1 intercept. So let's think about what's going on here. When A was positive and Q was positive, then there was no x-intercept. When A was negative and Q was positive, there was 2 x-intercepts. When A was negative and Q was negative, there were no intercepts. And when A was negative but Q equaled 0, there was 1. You see the pattern. When the signs are the same of the A and the Q, there's none. When the signs are different of A and Q, in other words, one's positive, one's negative, there's 2. And when Q equals 0, regardless of A is positive or negative, there's 1. So keep this one in mind. It's a good question. Now it's your turn to try. I want you to head on over to the Quadratics. I want you to do questions 7A and 8A and check your answers at the bottom. And again, if you're a Sync student, send me an email and let me know how it went. It could be good or bad. If you think you're bugging me, you're not. I always want to hear from you. When you're finished that, it's practice time. Continue with the rest of the questions, always keeping in touch when you're having troubles. It's really important to master these skills. This is just going to improve your confidence and often in your grades. Well, that's the end of the Vertex Forum video. If you have any questions, please let your teacher know. I hope you have a great rest of your day.